Okay, cool. So hi everyone. So I'll give a brief introduction of myself first. I'm Kristen from Security Research Labs. We are a company based in Germany and also having a satellite office in Hong Kong. So I'm actually from the Hong Kong office. And my work in Security Research Labs is mainly focusing on SOC optimization, helping other organizations to improve their SOC operations or their SOC infrastructure. So I would love to take the experience that I learned from different organizations and give a lesson of how you could build your own SOC and make it better than the organizations out there. And also, of course, other than doing SOC work, blue team work, I also spend many times in doing like maturity review, helping other organizations to improve their overall corporate security, and also do many pen tests and red teams. So I can also have the attacker's mindset when I'm designing defense for organizations. Yeah. So that's pretty much my background, and let's get started. So here's a quick agenda of like what I'm going to present to you in this session. I'll have an architecture overview so you can learn the infrastructure components in modern SOC, and also like syslog forwarding, some technical guide on how you can set up logs forwarding into the SIEM, how you can parse the logs to make sure the data quality is good, and also normalizations. So those will pretty much get you set in building and starting a SOC. And then I'll have some high fidelity alerts that I would like to share with you so you can start to defend your environment with those alerts that we would like to suggest. So in case not everyone knows how a SOC looks like, this is actually quite a classic and accurate picture of a SOC room. So there will be many analysts in a room looking at dashboards, looking at alerts to react and respond to the attacks happening into their organizations. And the main function of this are as follow, like there will be a storage in the system where you can easily query and check the logs of the history to see what events happen at what date, so you can investigate whether some malicious attacks happen at a given time frame. And you could also perform some automatic analysis there, so you can set up some query, some analysis that is scheduled every hour, every 5 minutes to help you to detect alerts. And of course, yeah, you have the alerts function, so you will also connect this SOC room or the SIEM solution with your like email or some webhook, so that whenever some alert is triggered, you will receive email, or some other connector will also receive the alert and do some follow-up automation as well. And so after those like general functions, if you want to like start to do some hands-on stuff, the common solutions that you will be expecting are like Splunk. I think it's acquired by Cisco right now, and it's also quite a nice leading solution. And of course, Sentinel by Microsoft, also quite popular one, because you have the whole ecosystem with the Microsoft suite. And then also after those, there will be some open source tools like Elasticsearch and also Wazoo. And there are also many more other solutions, but I think these four are the most quite common solutions that I encountered in my client experience. So before we dig into the actual content, I'd just like to raise your interest on like why this presentation will be helpful or interesting to you. So no matter what background you come from, I think there are certain benefits you will be taking from this presentation. So if you are a blue teamer doing a lot of defense work, definitely this helps you to maintain a better SOC, so you can learn how to like how to set up a better log quality, how you can experiment and play around with threat hunting, and also like even if you go one step more advanced, it's like trying to set up some honeypots so you can have more proactive detection than reactive detection. And if you are a red teamer's background, it's also very helpful for you to learn how SOC operate, because then you can experiment with a SOC and test what is the upper limit and lower limit of detection. For example, for me, because of my SOC background, when I'm inside the red team operations, I am very familiar and experienced in like checking what kind of EDR solutions are on the host, and also what kind of logs forwarding is happening on the host, so that I can actually apply my blue team skills in my red team to silently drop and remove those logging stuff, and then the host can be unmonitored, and then I can take advantage from that as a red teamer. So I would really encourage any red teamers or offensive background people to also play around with SOCs so you can improve your operation stealth. And lastly, if you are neither red nor the blue team side, if you're just like a self-hoster or a hobbyist, I still think it's very fun to build your own SOC and protect your own infra. For example, for me, I also self-host stuff. I self-host like my own Joplin node server. I host my own proxy, VPN, etc. So it's also very fun and interesting for me to monitor how my infrastructures are interacted with other public scanner or other people out there in the internet. Yeah. So I can sometimes see what are the word lists that people use to brute force my web applications. I can also see what are the username that people try to log into my SSH. So that's actually quite fun. Yeah, so like the overall takeaway that you all have is like, how do you configure the correct data format, and also like a cheat sheet for configuring the RSys log, because this was something that I had so many headache in the past, and I hope I can also share my cheat sheet with you so you can not go through the same hustle that I had. And some detection suggestions that I will also give at the end. Yeah. So in our presentation, I would like to use this example environment for illustrating how these syslog forwarding, parsing, and normalization plays a key role. So imagine we have this environment. We use Splunk for our SIEM solution to monitor and analyze the logs. And we have two different kind of web technologies. One is Apache, one is Nginx. So we can imagine them generating different formats of logs. And we need to make sure that these two different logs can eventually be unified in a good quality at Splunk. And then we can use one single query to protect both of them. So if our scenario is a very basic directory brute force attacks, where an attacker tries to like throw a word list on your applications to identify and fuss what are the available endpoints on your applications, that's the attack we try to detect. And the logic we'll be using is like check if there's any like high volume of requests coming from the single source IP in a short amount of time, like 5 minutes. So with that scene set, we shall take our first step to forward the logs into Splunk. So I'd like to give you a architecture overview first. So in an ideal pipeline or in a SOC setup, essentially the nature of it is data science or data analysis. So we'll have log sources or our data source, for example, our network device, CI/CD servers, Active Directory, etc. And you would forward those logs into the preprocessor, maybe, depending on how advanced is your stack. So the preprocessor can help you to do more processing or enrichment on the data quality. For example, some logs, they might be missing timestamp, or the timestamp is in a very weird format. So you can configure your preprocessor to do some transformation on the timestamp to make sure the timestamp is correct when it actually arrived at data storage. Or for example, some logs might be having some weird spacing or some special character, and that might prevent it being indexed properly in the storage. You can also make use of the preprocessor to remove or change those special character, or maybe sometimes the logs is coming in a JSON format and it's very noisy, like it could have like more than 100 different kind of fields, and that's too much for your storage. Your storage will get full very quickly. So you can also do some filtering in your preprocessor to, let's say, like I only want to keep 10 fields in the JSON, and others I want to discard. So then the preprocessor will be quite handy in doing this preprocessing task. So you can save your storage at your actual scene. So lastly, you have the whole stack for like storage, analysis, and monitoring. Depending on the solution that you're using, some of them can be like all in one, like Splunk. You see, Splunk can do both the storage, analysis, and monitoring at once. But if you're using Elasticsearch, you have to configure them differently. You will configure one Elasticsearch for data storage and analytics, and you also need to configure an additional Kibana instance for actual visualization. So depending on your stack, your components will be slightly different, but overall, the concepts are here. So if you want to like do some home lab, I would recommend these three for you. So the Elk stack are the like Logstash, Elasticsearch, Kibana stuff. Those are open source, and they can be like free, and so it's quite useful for home lab. And Crypto as the preprocessor part, they also have a free version, and it's available as long as you have less than 1 GB daily ingestion. So it's more than enough for just home lab. Similarly for Splunk, it's not open source, but there is a free version for people to practice. The limit is also like 500 megabytes per day. So it's also more than sufficient. So I think these will get you started. So as we mentioned, forwarding the logs is the first step. And when it comes to forwarding the logs, I observed many mistakes in enterprise or organization is they are just forwarding the logs into the SIEM, but they are not considering the logs format. Because if you want to forward it, actually there are already like 4 different options. As I'm illustrating, like you can forward the raw format. You can also forward it with the RFC 3164 or the RFC 5424. Those are the syslog formats. And sometimes, the SIEM like Splunk, Elasticsearch, they only recognize the logs if you send it in a specific format. So, the organizations, they just randomly forward the logs in a random format. And at the end, the SIEM is not recognizing it. So the effort is kind of wasted. So it's very important that you should understand these formats before you get started with with your SIEM playground. So raw logs, it means like just some logs generated by the application, like SSH, sudo logs, some web access logs. You can check them at if you're on Linux, you can see them at like the /var/log directories. And the features or the properties is like, those logs may not contain all of the key information for a holistic monitoring. For example, like host name and software name are not present always in those logs. So because of that limitation, people invented or established a standard for syslog, which is RFC 3164 and 5424. So with the syslog format, it's defined and mandates certain important fields present. For example, timestamp, hostname, process ID, etc. So if you're forwarding logs in a syslog format, you have more verbosity and it's more detailed. And FYI, the 3164 is obsoleted, considered legacy, so we should actually use 5424 for any future syslog forwarding. However, the caveat is many SIEM are still actually recognizing 3164, and depending on the log sources or version of SIEM that you're using, they may not support the latest 5424. So you need to do some homework before you forward the logs. Double check your SIEM, double check the parser to see which format that they are accepting. Yeah. So other than syslog format, people find syslog are still not verbose enough, not containing all the different fields that they are interested. So people also establish another standard called common event format. So this CEF is actually based on syslog, but it mandates and standardizes some additional metadata. For example, like device vendor, device product, etc. It's mostly useful in large enterprise environment. So imagine in a large enterprise, like their firewalls, they're probably using mixed vendor solution. They might have checkpoints for their firewall at some location, and they also use Cisco firewall at some location. So because of that reasons, for those companies, having device vendor, device product is very important in their logs. So they might use the CEF format. Yeah. But actually for us, or for my experience, most of the time, just using raw logs or RFC format will be sufficient. Yeah. So, out of the different misconfiguration, I would like to highlight the most, common and the most funniest I've seen, with you, which is the timestamp. So, timestamp seems very trivial, but when you're configuring it, there are actually many details underlying. For example, the first one we see very often is missing the time zone. So sometimes for some organizations, which they are very big, they have different geolocation sites. If you don't have a timestamp, then the SIEM can be confused with your time. Like maybe the logs are sending from Bangkok and your SIEM is actually set up in USA. So then if your logs don't have the timestamp, your US based SIEM will automatically use a US time zone for your logs, and then you will have a messed up timestamp. And then the second one that is even more common is like using abbreviation. So some people might think that if we use like IST for Indian time, it can be quite clear. But in reality, it's actually confusing because it can stand for Indian Standard Time and also Israel Standard Time at the same time. So we actually had an experience with Elastic that we were sending logs into the system using IST for an Indian client, and then we were not able to search our logs because all the logs are coming from the future, because like Israel is like a few hours ahead of it. So then later on, we need to use mandatory numeric offset. So in the best practice, you should be using numeric offset to denote what is the time zone. And we should not be, if we want to be responsible and as clear as possible, we should not mention about ISO standard or RFC standard, because based on that beautiful graph, you can actually see there are many variations within RFC and ISO. So if you tell the client or tell the people to use whichever RFC format, it's actually still ambiguous and unclear. So I have selected the best format, I think, which is this one. Like for example, if Indian is UTC plus 5 hours and 30 minutes, you will have like this plus 5 and 30 minutes. So this is the clearest timestamp notations, and by my experience, this is always recognized by the SIEM, and the most reliable as well. So this timestamp format is somewhere in the overlap between RFC 3339 and the ISO format. So if you use this formats, you also can ensure the compatibility between RFC and ISO format as well. So, lastly, for our syslog forwarding, I have a cheat sheet for you. So depending on your SIEM's requirements, if you need to forward it in raw logs, which means that you don't want any syslog header, you can use this configuration. And if you need to forward it in RFC 3164, you can also follow this configuration. So for each of these, I also attached a screenshot of the TCP dump to verify that this format can indeed generate the format that I am showing you. And I believe the slides will be available on the website later, or you could reach me out on LinkedIn. I can also drop the slides with you. Yeah. So back to our settings. If we want to protect our Apache and Nginx server, now we have forwarded the logs. The next step is to parse the logs, and I'll explain what does it mean by parsing. So parsing refers to extracting the fields in the logs and index them. So on the left-hand side, you can see in the drop-down table, these are the values that the SIEM has recognized and extracted them. But you can see that it didn't extract the URL or IP address, which means if you want to search for a specific IP address in your logs, you will be using a full text search, and the performance is slow if you are in a very big setup. So in an ideal setup, you should see the logs being parsed, and you can see these values being extracted correctly, like source IP equals to 223 something, and also what is the destination address that it's going, how many bytes are being transferred in the in this connection. So this is what you should be expecting in a well-parsed setup. So this is also one common mistake that I observed in many organizations, where they are not having these fields being extracted, but they thought they had. So in a very classic and silly example I encountered with my client is they were monitoring the outbound URL people are visiting by the proxy. So they have some blacklist for alerting. For example, if you try to visit GitHub from a production server, that should be discouraged, because GitHub contains so many different tools that you can download. So that should be flagged. And in a production server setup, everything are all set, and you should not be seeing people visiting GitHub from your production server. And so they have a detection rules that alerting when the destination equals to GitHub. But then in their setup, they're actually on the left-hand side. They didn't have the destination extracted, so they always receive no alerts for those detections. So we had to fix that by setting up a proper parsing. So here I want to show you how you can configure parsing. So in the beginning on our architecture overview, I mentioned there are different stages in the data pipeline. So when you're setting up the parsing, you can also do it at different stage. So the first one is agent-based parsing. So you can install an agent software on your servers, on your network device, and let this agent parse for you. For example, on Active Directory, maybe you can install an Elastic Agent on it. So Elastic Agent will do all the nice work for you to go check the Windows event logs and transform them into a proper format before sending it into the Elasticsearch. So you can also distribute the parsing computation to those agents and save your CPU resource on your central SIEM. And another approach that we are now seeing is this middleware parsing. It's gaining more popular from my client experience, mostly because those enterprise has misconfigured their parsing for so long, and they are unable to make change on their log source, and they are unable to make change in their SIEM. Therefore, they insert a middle layer in between and let the middle layer to reconfigure the parsing, so that they don't need to make any change to their SIEM or make change to their log sources. And then the third one is like index time parsing. So this one, you have two options. One is to try downloading some pre-built plugin, which I will actually show later. If you're in Elastic, you can go to this Elastic integrations, or if you're on Splunk, you can also go to their add-on stores to try to find available plugins. So you can handle the parsing quite well from the time that it's doing indexing. Other than that, you can also define your custom regex expression for parsing the logs. If you're in Elastic, you can set up something called ingest pipeline to set up your regex and do the parsing. Or if you're on Splunk, you can check out these two configuration files to set up your regex as well. So lastly, the most nasty one, I think, is actually the search time parsing. So before you do any kind of search in your queries, you can also do some inline regex there at your search time. So this is quite redundant, because every search you will have to do the regex one more time, even though you are searching for the same log. So this is not so the performance for this search time parsing is not ideal, but in practice, we see this very often in our client as well, because this means that you are not modifying your infrastructure. So people are willing to sacrifice the search time performance for avoiding the infrastructure change. So I'd like to give you an example of how I configure the Nginx parsing. So as I mentioned, there are some like add-on plugin that you should search for, and that's usually the most easiest way and the most safe way for you to configure parsing. So nowadays, most of the popular software or applications, they should have these kind of plugin published on the SIEM's store. So you should always check out those before you try to invent the wheel for yourself. So I downloaded it, and then of course, we should always check the instructions. So I checked the instruction from the plugin that is that I should configure the Nginx access log in a certain format so that it can recognize it. So we just follow this and make change to our Nginx config and ensure the format will be recognized by the plugin. And then lastly, we also need to like set up some input receiver on your SIEM to receive the Nginx logs. So in my example, I use UDP. So I open up an UDP port specifically for Nginx. And you can see I need to select the source type as the Nginx, so that the SIEM, when it receives the logs on UDP 1001, it knows that the format is a Nginx format, and then it will parse it and extract all the values from the logs. And then as I mentioned in the beginning on the logs forwarding, there are several options for you to use. You can use like raw logs, RFCs 3164, RFC 5524, and here I basically just did some like trial and error. I first tried to forward the logs in the RFC format, and then I checked my Splunk. I realized the Splunk are not recognizing them, so I just move on to try with like the raw log format, and then just work. So then I verify in the Splunk and click on the drop-down menu to see that all the fields are being extracted successfully. Then I call it a day and concluded the logs onboarding for the Nginx is successful. So as you can see here, we can see the number of bytes being transferred in the connection. We can also see the destination ports, and also the host that we're requesting it as well. So this is how you would expect a successful parsing looks like. So many people might have called it a day after they completed the parsing and think that the SIEM is ready to go. But actually there's one more steps that not so many people highlight or aware or underestimated, which is normalizing the logs to make sure the fields naming are consistent between the different log types. So this is actually some example we extracted from real life. So there's a random web application logs. You can see the naming scheme is different from another application logs. For example, it was using like HTTP method, and another one just used method, and like ERI path, and another one used just path. Like also like size versus bytes. So these inconsistent naming scheme can actually give you a big headache and troubles, because when you try to create a detection rules, for example, a data exfiltration rules, you want to monitor all of the connections that are sending large bytes out. So you might create one detection rule saying that if the accumulated bytes are bigger than 5 megabytes in 1 minute, we alert it as a data exfiltration. But then you will have a blind spot on another application, which is using the size as the name. So it's very important that you should unify the naming scheme to make sure that they are using the same scheme. Yeah. So then this brings us to another question, that what naming scheme should we use? Is there any best practice? So, of course, yes and no. So there are naming schemes by different products or different solutions that you are using, but there is no golden standard for all the different SIEM solution. For example, if you are using Elasticsearch for your SIEM, you need to refer to this Elastic Common Schema. And if you are using Splunk, you need to refer to this CIM model, the Common Information Model. And you can look up on their official website to check out what are the requirements or the specification for different type of logs. For example, if you're using Elasticsearch, then source IP should be named as source.ip. And if you're using Splunk, you should use src_IP. So you can see the difference between different standard. So yeah, you have to adopt this naming scheme depending on what SIEM solution you're using. And by doing so, I would imagine having a quite nice, standardized and consistent namings. So here I want to illustrate what are the options for you to configure the normalizations. So the first one is, of course, try to modify the parser's logic to name the fields consistently. So depending if you're doing like agent-based parsing, or like index time parsing, or doing at preprocessor, you can try to inspect the configuration of their parsing and modify their namings. So you will be fixing the problem from the root, which is something that we always want. However, there's like a deal breaker that you might break the future integration of the parser. For example, because you modified the configuration of the parser, in a future update, maybe it cannot be updated. Or in the future, when it is updated, you have to reconfigure it again. So it's actually not very ideal. And the better practice that we see from our clients and our experience is doing this like search time parsing. So you avoid touching your parser functions, you avoid breaking them. But you might increase some search time overhead. Your search time will be slowed, and but that's actually fine for companies. It's actually fine to like spend 5 minutes on one query, because those are like scheduled stuff. So many company are willing to sacrifice the time for not touching their infrastructure again. So by what it means by search time normalizations, it's actually like this. So before they make any search in the system, they will prepend this list of query in the beginning using the coatus command to unify the namings between variables. For example, as you can see, like they are unifying bytes and size into bytes, and unifying HTTP method request method into HTTP method. So you can see, like, if you are going to prepend this chunk of queries at all your search, it's going to be slow. But the reality is, people really can't afford touching or reconfiguring their infrastructure. You might have to go through change management, architecture review before you can actually make change to your parser. So it's actually faster in terms of process by just prepending this chunk of queries in their detection rules. So they don't need to go over those enterprise process in changing infrastructure. So back to our example with Nginx and Apache, we could already see and highlight some of the difference. For example, in Nginx, we are using source_IP, and in Apache, it was using client. So this kind of normalization thing really do happens a lot. So if this happened to me, I would use the search time normalization as well, like prepending a search query. But more luckily for us is we can see they both have this source field. So we can actually just use the source field, but not using the source IP field. And my understanding on the source, the difference between source and source IP is source sometimes can represent the host name, but source IP is always going to be an IP. Yeah. So in some settings, if we know that if it's not critical for us to ensure the value is always an IP or always a host name, it's actually fine to just use the source field. Yeah. So now, if we have forward the logs, parse the logs, and normalize the logs, we can actually start creating detection rules. So in my example, what I did was, so you can see I use one single queries, and my queries can pick up alerts from both different source type. So you can see at what time in a 5-minute window, what source IP has performed directory brute force. So it counted there are distinct 220,000 different paths that a source has tried to first. And we can also list out all of the attempted paths so that we can get a word list. And yeah, so this is from my own lab. So I just do it on the same machine. Therefore, you see it's from the same source. And so other than this, I'd like to start to give you some starters for the high fidelity alerts that you can play around. So in our philosophy, we believe and we have high faith in doing honey token or honeypots because these are more proactive detection than conventional detection. Because those conventional or traditional detection rules are quite easy to be bypassed. You can do it slowly. For example, for directory brute force, as an example, you can brute force them by manually. So you reduce the number of path that you are visiting in a short time, then that can evade quite effectively. Or you try to use different source IP to brute force as well. But with honeypot and honey token, there is an advantage that you are setting up something that is dummy and you are not expecting anyone to interact with those honeypot or honey tokens. So it gives you a very high confidence and high accuracy that if someone has touched them, something bad happened. So we list out some common honeypot and honey token that we've seen and tried helping our client to deploy, like fake database table. So this one is actually quite nice because, database is massive and like there are so many concurrent read-write actions happening onto database. If you onboard the database logs, it's going to be very noisy. It's going to be having a lot of volume. Your cost for hard disk storage will also increase a lot. So what you can do is create a fake database table and then only forward the logs of like someone read that database table. Because in normal sense, if the application is running in a automated manner, it should always be touching those very few tables only. So if someone has read the table, you know something bad happened, like someone may have successfully launched a SQL injection, or someone has compromised your database server and viewing it from the host level as well. And also like fake API keys, this one is also very prevalent and very easy to deploy. There is a application or say a solution called Things Canary. Maybe some of you have heard of it. So they actually offer some free API keys that you can download from. You can download some or generate some fake API keys from Things Canary and deploy those fake API keys in your storage. So whenever those API keys are being used, it will trigger an alert in Things Canary, and Things Canary will tell you that someone just tried to log in with the access key that you generated. It means that the place that you the storage that you placed the API key is compromised. Then you can investigate the storage. Also, you could put some like fake document in some critical file system. For example, what we would recommend our client is, let's say they have some very important SFTP backup server. They could also try to put some fake document in the SFTP server. So whenever the attacker has downloaded the dump in the SFTP, and when they open the fake document, the document will trigger some DNS callback, and then they know that someone has downloaded and exfiltrated the data. Fourth is a dummy server, which is actually also very useful. So you can deploy a dummy server in your network that whenever someone scanned its port, whenever someone visited a URL on it, you fire an alert. And you could integrate this server slightly with your infrastructure. For example, you actually create a hostname, DNS name for your server, and you register the DNS record in your DNS zone, and also you register the server in your Active Directory, so that when attacker compromised or gain a foothold in your environment, you can trick them to scan your dummy server if they ever enumerated the Active Directory machine list, or if they ever done some DNS enumeration. For example, one techniques that we have done in our red team is we would query the IPA server, which is the Active Directory in a Linux environment, to query all of the machines inside a network. And then we perform DNS enumeration on all the hostname to resolve the IP address. And then we perform some very slow port scan on it. So that technique was very effective in evading any IDS, IPS solutions or detection, because we were doing the port scanning and the port sweeping in a very slow manner. And so that will be the scenario where you would wish you have a dummy server, because a dummy server doesn't care whether you are scanning it slowly or fast. It always raises an alert even if you only scan it once. So it's a very helpful honey token to deploy. And lastly, the last three one are the ones that I would like to give you some demo and more in-depth discussion. So these are all related to Active Directories, and I believe Active Directory is nowadays the most trending or popular system that hackers aim for. So I would highly recommend you to go ahead to try these honey tokens. So the first one is the curb roasting. So to detect curb roasting, maybe let me explain what is a curb roasting attack for someone who doesn't know. So the prerequisite for curb roasting is actually very easy. As long as you have any valid AD account, you can launch the attack. You don't need a high privilege account. So in many assumed breach or phishing scenario, once the attacker gained access to one of the Microsoft AD accounts, they already can launch this attack. So what they would do is to query all the users in the Active Directory system and check which user have this SPN attribute set. So if an account has SPN attribute set, you can request a so-called service ticket of that account. And once you receive the service ticket is actually encrypted by the target user's password. So you can bring the service ticket offline for password cracking. And it's very prevalent attack because there are many people using weak password, and like they might not be using password 123, but they might be using the organization's name as part of the combination. For example, if we are like out of the box, people might be using OOTB 123 as their password. So you can apply these characteristics to generate work list and crack the password quite effectively. And the challenge to detect curb roasting in traditional detection approach is there are many noise in AD environments because service ticket requests are very common in AD network. For example, when you try to access a file share, you would request a service ticket of the file share. When you try to query LDAP, you also request service tickets. Or you try to open up a WinRM session that also involve service ticket requests. So you can imagine in a large network, there are huge volume of service ticket requests. So it's very difficult for you to distinguish which one are for curb roasting. So therefore, our recommendation is create a dummy user account with SPN set. So this dummy account is not relevant to any application. No one should ever request the service ticket of it. So you can also configure the encryption algorithm to RC4 to increase the chance that attacker might request it, because there are several available options. You can use RC4 AES encryptions, and RC4 is the most easiest to be cracked. So attacker usually would also have more interest to crack RC4 tickets. And then you can try to monitor this event ID I outlined, so then you can start to detect curb roasting. And let me show you how it actually works. Okay, good. My session is still here. So this is my Splunk setup. Yeah, so here is like the traditional noise problem. If I just search for these two events, you can already see there are some regular service ticket being generated. So if it is a real life environment and if it's a bigger network, you can see a lot more volume than mine. So if we want to detect it, let me demonstrate how we would attack. So depending what OS you are on, for example, I'm now on Windows, then we can use Rubius. And if you're on Linux, you can also use Impact Suite to perform curb roasting. So okay, yeah. So we type this command curb roast. So this is a automated attack, not the most advanced, But what you can see is, let me scroll to the top. Maybe I should like make it full screen. Let me unplug it. I think the cursor is not anchored correctly. Yeah. Yeah. Just a brief explain about Rubius. So Rubius will actually try to first make this LDAP query to try to find any account in the network that has SPN set, and to make sure that they are not machine accounts. And then they will find the number of curb roastable users and automatically request the service ticket of those accounts for you. So in some more advanced attack scenario, you can specifically curb roast one account only instead of curb roasting all the curb roastable users. Oops. My network also just disconnected, but never mind. So what it does, you might already have seen there were some hexadecimal characters printed. That is actually the encrypted ticket. And as an attackers, we will bring those tickets offline and try to crack them. So if we want to like detect it, you can already see like this curb account was requested. So we have quite a high indicator that this curb, someone just performed a curb roasting. So I can also do this. Yeah. So like we can see that someone has performed this, and we can go to more details. So we can check the access logs that which account performed this service ticket request. We can look at that. It's the account is the administrator. So then you can trace back to this user and ask him why he did it, and check if his account was compromised. And you could also see what was the address that he used for launching the attack. So you can also identify and pinpoint the endpoint that was compromised as well. So this is a very simple and effective way to detect curb roasting in Active Directory. And then the next one that I would like to show you is AD enumeration. So I assume and imagine many of you have tried like Bloodhound for collecting AD data. So before we launch any attacks in Active Directories, it's very common for us to first gather and enumerate the environment. We will make use of LDAP to query what are the accounts available inside the Active Directories and try to map out their relationships. And then we can launch our abuse based on the relationships that we have mapped. For example, you can identify what are the permissions available on your users and also what are the permissions available on other users. So sometimes the approach will be like we gather the data from Bloodhound and we check what are the permissions on our users. And let's say our user have control to reset password of another user. Then we can try to like reset other users' password, and then we can gain control on another account, and then we check again what is the new account's permissions, and then we further like move laterally. So AD enumeration is something that you definitely want to detect, because that is usually the very early stage of an attack happening. So if you can bust the attacker at this stage, you have a very great winning. So again, the detection setup will be like this. You can create a dummy user account, and then you can enable auditing on like read all properties. so that if anyone tries to read the properties of this account, you know that someone is enumerating the network. Because when people are running Bloodhound or Sharphound, it's always automated tools. So it just do massive read actions on all the accounts. So it's very easy for you to detect those tools usage if you have done this. And you can monitor these event ID like 4662 to check this, and make sure you use the account's GUID instead of username. So let me show you how it will work. So this is the query that I will be using. This was the account that I set up as a dummy user. So I will monitor if anyone done some enumeration on it. So can we do like date here? Okay. Yeah, so if we run Sharphound and try to collect data, you can see that it's collecting massive amounts of data, like what are the access control lists, what are the available users. It will collect many data so that you can make use of this data to map out the environment and plan your next steps for launching attacks. Yeah, so after it's finished running, we can go back to our Splunk. Yeah, so now we see a few more entries. We can see that our account was being requested. Someone tried to read the properties of our dummy account, and then you know that something bad is happening, because normally no one would really read it unless he's an administrator very bored, or some attackers was doing these kind of enumeration automatically. So for example, we can see that this account, this subject administrator performed a read property on our account. So you can see what kind of things that he read, and you can also see what are the GUID of the properties that he tried to read. So you can see that administrator has tried to read a lot of things from this account. Yeah. And some of you might think that if I don't use Bloodhound, I use something more manual, will this be able to catch as well? So I have an example where I'm using manual LDAP search. So this is actually a very a query that I like to use very effectively. So we would query the LDAP from the root DN. So I'll basically just pull all the data if it ends with srtest.internal, which is the domain that I'm attacking. And with just one query, I will export all the information from the domain like this. And this query will work on both Windows Active Directory or Open LDAP or free IPA environments. So this is quite useful, and I just get everything in one query. And yeah, so I just run that, so you will see this actually also triggered a few more events. Yeah, so this detection is very simple and effective. That helps you to detect many kind of AD enumeration, no matter it's doing like manually or using Sharphound. Yeah. Right. So the last one is like a ADCS honeypot. So in Active Directories, there's also a certificate service. So not only you can use password to log into Active Directory, you can actually use certificate-based authentication if your AD have set up certificate service. For example, if you log into your company by smart card, like entering the door in the morning, that's also like a certificate-based login. So there were some vulnerabilities, actually many vulnerabilities about ADCS, and it's also very hard to distinguish them. Therefore, we had actually released one tools called Certiception last year, I think. And I would love to redirect you to check more details on our GitHub, because my colleagues have done a lot of work and documented them very detailedly on how you can set up an ADCS honeypot as well. So it's like here's Certiception GitHub. Okay, I'm still. Yeah, so 1 year ago, my colleagues at Balthasar, he also released this like Certiception, has a very detailed walkthrough on how it works, what's the background, and also like how you can deploy it with Ansible as well. So I really recommend you to check this out. And I think this is also like the end of my oh no, just one more last slide. This is just a very quick overview of like this, the logs that you should onboard as a starter, so you can play around with. Yeah, like Linux OS, you definitely should onboard like the authentication logs for your like sudo su ssh from these two paths, and the Linux oddity logs to monitor command executions, and also like Windows event logs, like from the security logs, PowerShell logs, and also web access logs. So these are the good starter logs for you to get started. So some of my references, and yeah, thanks everyone. So feel free to reach out for more offline discussion. Thanks. Any question?
Yeah, we are out of time, but we've checked with the next speaker. He's happy to give, for us to take time for questions. Anyone with questions for Kristen on stage? I won't be surprised if you will have off-stage questions as normal, but no? Okay. All right. Well, thank you very much, Kristen. Really appreciate this talk.
Thank you. Thanks.
Please join me to thank him.